Welcome to the Laboratory Prerequisites Lab. To have a meaningful Hyper-V lab environment, you need to have a solid plan for networking. An acceptable plan is to simply run all of your virtual machines on the same external Hyper-V switch. In fact, for most labs in this curriculum, you can get away with basic networking from your home router. What this means is your home router would handle all network traffic, including access to the internet. Your home router would also most likely hand out IP addresses and DNS information via DHCP. For a Hyper-V lab environment, this can be a huge limitation. You are limited to only one subnet, that is the subnet that the router is using. To me, labs start to feel a bit unrealistic if devices for the entire lab are on the same subnet, especially as the labs start to grow. Also, in some configuration scenarios, every virtual machine cannot be on the same subnet. During my studies, I developed a solid methodology to use a Hyper-V virtual machine running Windows Server as a router. What we will do is install the remote access role on this Windows Server and configure the server to be a NAT router. I also configured this same Windows NAT router as a DHCP server with multiple scopes. This is a convenient way to hand out IP addresses along with DNS information to different servers that belong to different local area networks. Each subnet has its own network adapter attached to the Windows Server, and these adapters are configured as the default gateways. This means all you have to do is start a VM on a particular subnet, and it will be assigned an IP address, the default gateway, and the DNS information of the domain controller for that domain so that we can quickly add the machine to the domain. So I made this diagram to illustrate the configuration. So we'll have 6 network adapters attached to a Windows server called Yahoo-RAS01. We'll configure 5 of them. We'll connect 5 of them to private Hyper-V switches, and then we'll connect 1 to an external Hyper-V switch. That one will associate with my Wi-Fi adapter. My Hyper-V host is a laptop, and we'll be using the Wi-Fi adapter. So a common IP address scheme for home routers is 192.168.1.0/24. So this interface will get an IP address from my home router with the gateway and the DNS information as well. So the other 5 networks, they have DHCP scopes that are handled by the Windows Server. So for example, in the Anchorage LAN, the scope for it is set up to use 192.168.77.0/24. So we'll get an IP address from that range, and then we'll be assigned the 77.1 for the default gateway and 77.7 for the DNS information, which will be the DNS server on the Anchorage LAN. So all of that information will be programmed into the Windows Server, and then we can quickly add it to its domain. The way that the network traffic works, so continuing on with Anchorage LAN as the example, originating traffic from the Anchorage LAN would travel to the router, out the external internet, the external interface, to my home router, and then to the internet. The return traffic would hit my home router, get routed to this external interface of the Windows Server, back to the Anchorage LAN. So one of the reasons this strategy is so effective is that all of these LANs have connectivity within each other. So if we, for example, just removed the Wi-Fi external network altogether, all of these networks would still have communication with each other. In the real world, each one would have its own router, and you would probably have to do some kind of VPN configuration to have that kind of connectivity. But here in the lab environment, we can just stand up one Windows Server with multiple network adapters to segment off these local area networks. This can be useful, especially in this curriculum, when you start creating trusts and different services within Active Directory domain services. So on my GitHub repository, I have the code that will be needed. We'll be standing up 4 servers. So we'll be standing up the Windows server as a router. And then we'll also just stand up a domain controller with some test users. And then we'll also stand up an instance of Windows Admin Center on Windows Server Core. And then we'll test the behavior from a management server called Yahoo-PA01. So that's a solid setup for any curriculum, for any lab involved in the curriculum. So it gives you a great starting point for any lab that you may encounter. So how this will work is I will talk about the code, execute the code, and then we'll test the configuration. So first we have to make sure that our Hyper-V host has the Hyper-V switches configured. So you can use the Hyper-V Manager GUI. There's also a built-in PowerShell module where you can use the new-vm switch command to create the switches. I also have created some custom functions in a Hyper-V quick create toolkit. That the link is in the description. So this tool will create all of these switches in one command. So next I also use a custom function to create a virtual machine from a generalized image of desktop experience for Windows Server 2025. This custom function also allows me to add adapters at the time of creation and associate them with a Hyper-V switch. So we're going to create this Windows Server 2025 virtual machine with 6 network adapters. We're going to call it Yahoo-RAS01. Each network adapter is assigned to the ER-NET private Hyper-V switch. We don't want to use the external one to eliminate the chance of my home router assigning more than one IP address to the server. Once we get inside the guest operating system, we'll rename the server, and then we'll get the current adapter set, and then we're going to rename the adapters, and this is within the guest operating system. So for each adapter in adapters, we will rename that adapter with a new name. So I create this array of strings, and then within the for each loop, I reference it by index to rename the network adapter. And then I also disable IPv6. For this curriculum, I felt by disabling IPv6, it just helped with troubleshooting when labs went wrong. I could just quickly not have to, or I could quickly rule out that IPv6 was having any kind of effect on the lab. So for this lab set, I have disabled IPv6 on all of the network interfaces on the Windows server that will be a router. So next we need to associate the network adapter to its Hyper-V switch. And you can do this manually different ways, but I came up with a good method to do this with 2 snippets of PowerShell code. So basically from the host, we will execute this line of code here. That is get VM network adapter by the virtual machine name. Then we'll get the net adapter based on the Hyper-V settings and what the MAC address is at that net adapter. And that's all from the host. Then we'll go into the guest operating system and just run the get net adapter command. And this will give us the MAC address by network adapter name. And then we can match the MAC addresses from the Hyper-V manager and then associate them with the proper net adapter. So the next piece is we'll assign each network adapter with a default gateway. So there's 5 private Hyper-V switches. So with the Anchorage example, we'll be using the 192.168.77.0/24 network, and we assign it 77.1. And then each this will be the default gateway for the Anchorage LAN, and then the other 4 interfaces are configured the same way. And then we also want to add a firewall rule that will allow the server to respond to ping. That way, as we're standing up servers and stuff, we can ping our default gateway for testing. So then we'll move on to installing the roles that we'll need. We'll need the DHCP role and the remote access role. The remote access role is where the routing configuration lives. So then I have 5 scopes here. For DHCP, we'll just talk about the Anchorage one as the example. There's some object variables that we define. So we give it a scope name, the range of the scope, the subnet mask, the default gateway, the DNS server, which in this case is the domain controller of that particular local area network, and its domain name. So in the Anchorage LAN, it'll be minecraftmoose.com. But you can see in the other ones, they have different domain names. So moosewire.fun, megamooselabsfun.com. So as we stand up virtual machines in these different local area networks, they will get the appropriate information programmed in. So then we add the server scope, we set an exclusion range, and then we also set the default gateway information and the DNS information along with the domain name. So next we'll move on to the routing configuration. When you're using the desktop experience, the GUI makes this much simpler. But if you want to do it on server core, you have to know the command line procedure. So here is the command line procedure, but you can also just use the GUI for a quick setup. So the first thing we have to do is make sure that the remote access role is up and running. Then we will create new NAT objects for each local area network. And then we will use the net shell command to configure the routing. And we'll configure our external interface to be our internet NAT facing interface. And then we'll configure the routing for the other 5 interfaces for private. So the key here is full and private. So this is our routing for our external interface, and this is the routing for the private interfaces. Then we restart the service, triple check the configuration, and at that point the Windows server is ready to be stood up. So we'll bounce over to our Hyper-V host. Like I mentioned earlier, I'm using a laptop. It's a Dell XPS 9520 using Windows 11. And then I have an Intel Core i7 with 16 gigabytes of RAM using 2 8 gigabyte sticks. Here's the Intel Core i7. So we'll also verify the switches. So I've got my 5 private Hyper-V switches and then my external Hyper-V switch, which is connected to my Wi-Fi interface. So this is the Hyper-V Lab Creation Quick Create Toolkit. So I'm just going to copy and paste this into my host. And now I have my custom functions to help with setup. So the first one I was just going to show is the create lab switches. So this command, if the ANCnet Hyper-V switch did not exist, it would create it. Otherwise, it spits out this verbose message letting us know that the switches have been created. But if they were not created, then this command would create them for us. But like I said earlier, you can just use the built-in PowerShell module for Hyper-V or the Hyper-V GUI. So we'll go ahead and create the virtual machine. So we've got our switches, and now we'll create the virtual machine with 6 network adapters. So after the command finishes, we'll get some nice verbose output about how the procedure went. And then we can also monitor the process here in Hyper-V Manager. And again, I'm using a golden image of Windows Server 2025 desktop experience. So it's copying that golden image to the default location for .bhdx files for Hyper-V, and then configuring the virtual machine with my custom settings. Now we get this verbose output about the network adapters being added, and then we can see that the machine is up and running. So right-click on the virtual machine, hit Connect. So the way that I configured this golden image, we'll get one prompt for the out-of-box experience. We'll program in the administrator password, and then we'll have a fresh instance of Windows Server 2025 with some custom settings. It's got a couple user accounts, MegaMan administrator account, and then Rush, just the standard account, a custom background image, and then the clock is set to Alaska Standard Time. So we'll get to the out-of-box experience here in just a moment. And this saves us from having to install from an ISO and going through the Windows operating system wizard, installation wizard. So here's the out-of-box experience. Click Next. Program in a good admin password. And now we're at the login screen of a fresh copy of Windows Admin Center. I'm going to stay in the administrator account. And the first thing we're going to do is just quickly rename the server to Yahoo-RAS01. And again, since I used a golden image, that's why I have this custom background. And once we get signed back in, we'll rename the network adapters. Oops. So a good shortcut to look at the adapters is network control panel applet.cpl. So you can see the default names are just Ethernet, and then it adds a number if there's more than one. And we can also use the get net adapter command. And we can also see the names that way. So I'm going to go ahead and paste in the code here. So here we get some verbose messaging about disabling IPv6. And now if we run the get net adapter command, we see that instead of just this generic Ethernet, they're now given a more descriptive name of the local area network that it's associated with, or external network. We can also bounce back here, hit refresh, and then we get a nice naming convention for all of our different network adapters. Okay, so now we will associate the correct network adapter to its Hyper-V switch. So we're going to use 2 command line shells. We're going to use the one within the guest operating system. And then we're also going to run some commands here on the Hyper-V host. Let me just get everything sized up here. And then we're also going to pull up the adapter settings. So here in Hyper-V Manager, we can see we've got our different network adapters, and they've all been assigned that ER-net. So now we have to go into each one and associate it to the proper network adapter, and we'll do this by MAC address. So here on the host, we'll run this snippet of code. And now we get this nice list of the net adapter name by MAC address. And then we need to do a similar action here within the guest operating system. So we just use the get net adapter command to get a nice list of MAC addresses. Now we'll start from the top of the list. So the first interface is this ext-int, ends in 0E4F. So we take a look at the list here, and that will be net adapter 2. So there's the 0E4F. So net adapter 2 is ext-int. Now we'll just go down the list. So ANCnet ends in 0E53. That's this net adapter 6. So this last one will be ANCnet. The next one is GNOMEnet, ends in 0E4E. That's net adapter 1, ends in 0E4E. So net adapter 1 is GNOME. So we'll keep going down the list. The next is the JunoNet, 0E50. So here is 0E50 for net adapter 3 will be JunoNet. Then Eagle River Net, 0E52. That's net adapter 5. That's already set. And the last one is LinuxNet, 0E51, which is net adapter 4. And so now we've set the proper Hyper-V switch to its network adapter. And so now you can see that we actually have connectivity to the internet. And so our external interface has pulled in an IP address from my home router. And then we'll configure these statically next. So we've got our Hyper-V switches configured correctly and associated with our network adapters. Now we're going to assign the default gateway address to each net adapter. And then we're also going to create a firewall rule that allows the Windows server to respond to ping. This way, when we stand up servers and need to ping our default gateway, we'll get a response for testing. So I've gone in here and statically assigned the IP addresses. So you can see here's 100.1 for Eagle River Net, AnkNet is 77.1, and so on. Okay, this next piece we're going to install the features that we need. We're going to need DHCP in the remote access role. So we'll go ahead and get that going. This will take just a bit of time, so I'm going to time compress the video just a bit here. With 1 GB of RAM, the server is just a bit sluggish. So it's a good idea to maybe use 2 GB of RAM during the configuration. And then after you stand up the configuration and you don't have to do much, then drop it back down to 1 GB. In this case, I just am using 1 GB, so that took just a bit of extra time. So now that we've got our roles installed, we'll begin with the DHCP configuration. So you can absolutely just use the DHCP GUI, but this illustrates the power of PowerShell. So I can just right-click, paste my code in here, and now it's going to stand up my DHCP scope with the default gateway information, the DNS information, to all of the different scopes. So all of that has now been created, and we'll take a look at it here in the GUI management interface. So this is our server, and then we've got our different scopes. So we'll take a look at the Anchorage one. We've got our address pool, which is the 192.168.77.0/24 range with an exclusion range. There aren't any leases yet. And then our scope options with the default gateway. And then an important part is the DNS information. So this is the domain controller of the Anchorage network. So this information will be programmed into any virtual machine we stand up so we can quickly join that machine to the domain. It saves you the step of having to go in and program in the IP address of the domain controller, because we predetermined what it is, programmed it in here, and now it will be programmed in every virtual machine that we stand up on the local area network. And then also the domain name in this case is minecraftmoose.com. So each one will have specific scope options. This one is 88.1moosewire.fun. And just real quick, we'll look at Juno, which is 99.1, 99.9 for the DNS server, and megamooselabsfun.com. So now we will move on to the routing configuration. So the first thing we want to do is just triple check that the services are up and running. And our remote access service is running. So next we will create the NAT objects for each of the local area networks using the new -nat command. And then we're going to use the net shell command to configure routing. So here we'll configure our external interface. You can see this full parameter, and then our private interfaces, and you can see the private interface. So this will get the routing configured. And then after we do the configuration, we'll restart the service. Okay, so the service has restarted. We're going to triple check the configuration. And we can see we've got our NAT objects associated with a local area network subnet. And then for our routing, we have our private interfaces and then our external interface where the address and port translation is occurring. So at this point, the Windows Server is configured to be a Windows Server. A small note about the GUI, even though it's all configured correctly, the information will not be displayed in the GUI. It will actually show the service is up and running, but it won't display anything. And I'll talk about that a bit later in the lab here. But if you're doing server core, that's it. That's the configuration. And even on the desktop experience, the configuration is set. But if you want to look at stuff in the GUI, there's just a bit of a caveat that we'll talk about at the end of the lab here. So we've got our Hyper-V router stood up with the DHCP server. So our next goal is going to be to stand up a domain controller, and we'll create some test users. So we'll get back to my Hyper-V host here. And for these labs, I'm going to use 2 gigabytes of RAM. I have noticed a performance increase when you use 2 gigabytes of RAM. So when we do the initial configuration, we're going to want to use 2 gigabytes of RAM. Especially with domain controllers, when you install Active Directory domain services and promote the domain controller, it's just much more snappy with 2 gigabytes of RAM. It'll work just fine with 1 gigabyte, but since this is a domain controller, we'll go ahead and use 2 gigabytes, mainly because we have the capacity right now. Okay, so we've got our new Hyper-V lab. We get this nice verbose message about how the procedure went. And now we can right click on the virtual machine, hit connect, and then we'll start the configuration for the domain controller. So it'll take just a bit of time here to get to the out-of-box experience screen. And again, this is a golden image that I've configured with a short out-of-box experience, a couple users, and a custom background desktop image. And this saves us time by not using the Windows ISO and the Windows operating system installation wizard. So here we are at the out-of-box experience. Click next. Program in a good admin password. And then we are in our fresh copy of Windows Server 2025. And you want to see this just to have better performance. So I didn't necessarily see that there, so I just closed it and reopened it. There's the 2 accounts. I'm just going to stay in the administrator account. And the first thing we'll do is just rename the computer. And the way that was actually fine. So first we're going to come in we're going to set a firewall rule that allows the server to respond to ping. We're going to program in the static IP address of the domain controller, which is 77.7. And then DNS points to itself for domain controllers. And then we'll rename and restart the computer. So here we are on the domain controller. And just in this one command set, we will set this firewall rule, set the static IP addresses, and then rename the computer and reboot him. So after the reboot, we'll install Active Directory domain services and then promote to a domain controller. So we've got a couple reboots here, which is also part of the reason I wanted to give it 2 gigabytes of RAM. Just, you can see it's much more snappy. So if you have the capacity, definitely use 2, but you can get away with doing the labs with just 1, just fine. So we will install the Active Directory domain services role. We'll see how this goes. I may time compress the video just a bit here. Okay, that took just a bit of time, but now we have the Active Directory domain services role installed. So now what we're going to do is promote it to be a domain controller. And in this case, it's going to be for the minecraftmoose.com domain. While the promotion is occurring, I'll just talk about a method I came up with to quickly create a bunch of Active Directory user accounts. So basically, in this example, I've created an array of strings, and then we will iterate through that list with a for each object. You could also use a TXT file and just have a list of like 100 people. And then use this same PowerShell code that way. But to demonstrate, I've just made it a comma-separated list here of strings. So we set what the domain is. The manager in this case is MegaMan, and then we will create an OU called Entra users, and here we just define a string variable called OU name. And then we also get the domain value. Then the path of the OU that we want to use. And then we create a new organizational unit with the OU name that we want in the OU path. So this will create a organizational unit that we will store the user objects in. And then I use the for each loop. So inside the object MegaMan 1, this array of strings is the bosses from the video game MegaMan. So you have Gutsman, Cutsman, Electman, Iceman, and so on. So the way this works is for each boss in MegaMan 1, we will use boss in the code. So for example, new AD user, the name is boss. So the name, the first one would be Gutsman. So in here we define some other parameters. For example, what office they'll be in, the distinguished name, their password, first and last name, username. So we use that information in the new AD user command, and that will create the initial user object, and then we will set information about the user in Active Directory. And this is important in later labs. This, when we do AD Connect, when you start syncing your domain controller into Azure, these are some parameters that will sync from your on-premise Active Directory instances into the cloud. So we'll check on our domain controller here, and we've got all the way to the first time boot up. One thing to note here is I used a golden image that had a administrator account called MegaMan and a standard user named Rush. So if that happens on the when you have local accounts on a Windows server before you promote it to a domain controller, it will add those accounts in Active Directory. So even though MegaMan was just a local account on the Windows server, it is now a user account in the Minecraft Moose domain. So this is now a full-on domain controller. And we're just going to quickly go into Active Directory users and computers and just take a look at those that were just local accounts to the server are now here in the users container. And then here's Rush. And then also when we look at the administrators group, MegaMan has actually been placed inside the administrators group. One thing to note is about the enterprise admins. You can see MegaMan is not an enterprise admin. So he is in the administrator group though. Okay, for this example, we can just continue to be MegaMan. So we'll pop in our server here in the command line. And we will create our test users. So we're in the domain controller. Here's our command line. It's going to create the organizational unit and then start creating the users. And so you can see it quickly created all of those users. So if you're trying to do a lab with 100 users, yes, you could create them one at a time with the GUI, but this will almost be instantaneous. And then we'll just go back to Active Directory users and computers, hit refresh. And so we made our custom OU, put our new OU our new users in the new organizational unit. That way they don't just get jumbled up in the default location. So we created a custom organizational unit, and now we have our users. And then when you look at these guys, like their description, Anchorage programmer, their email is programmed in there, their PO box, city, zip code, the manager, the company, job title. And the reason this is important is it will sync all the way up into Azure. And for example, if a user is using Teams, all of the information from your domain controller can get synced up into Azure and then applied to the user's Teams accounts, like their phone number, their title. And then it will also build an org chart in the cloud if you utilize the manager's property. Okay, so we've got our Hyper-V virtual machine running Windows Server configured to be a router, and we have our domain controller. And for most labs, those are the two core things that you'll probably need. At the bare minimum, you'll want to have the router, most likely, and then some kind of domain controller. But another key element in this curriculum is the Windows Admin Center. So the next part of the prerequisites lab, we're going to stand up a instance of Windows Admin Center on Windows Server Core. So the first thing we'll need to do is create a new lab, or excuse me, a new VM. And he'll be okay with just 1 GB of RAM. Server core is a little bit more efficient. So we will just utilize 1 GB of RAM. So I'm going to execute the command to create Yahoo WAC01. It'll be on the Anchorage net using a generalized image of Windows Server 2025 server core. Okay, we get this nice verbose output that the machine has been created. So open up Hyper-V Manager. There he is. And so the first thing we'll do is get logged in here and change the name. This part takes just a moment. Okay, so with this generalized image, we don't have to go through any of the first time setup installation for the operating system. We just get a fresh instance of server 2025 server core. So you can see how much quicker that is than installing from the ISO. Awesome, so now we will rename the computer quickly. And then we'll set a firewall rule that will allow the server to respond to ping. And we can see we got an IP address of 192.168.77.11. And then here is the domain controller. So when we ping the domain name, it recognizes that as our domain controller. So at this point, we can add the computer to the domain. So you can see within a couple of minutes, we didn't have a virtual machine. We stood up the virtual machine. We got all of the correct networking information programmed in. And now we're adding the machine to the domain. So while that's rebooting, we'll just pop in and take a look at the DHCP reservation. So this is on our RRAS server. Going to DHCP. Go into the Anchorage scope. I think I missed it. To the Anchorage scope, leases, and there our Yahoo WAC01 has been assigned that .11 IP address that we just found on the server. So next we'll bounce over to the domain controller, and then we'll look at the newly added computer object. Go in as MegaMan. And now we can see Yahoo WAC01 is now added to the domain. So we'll go back to the WAC server and begin the configuration. I'm going to use the administrator account of the domain. So this is the initial server config, and then we just do 15 to get to the PowerShell prompt, and we can see I'm the Minecraft Moose administrator. And we'll come back and we'll stand up the paw and add him to the domain after we do the WAC configuration. So in order to do this on server core, you have to know what the download link is. As of early May 2026, it's at aka.ms/WAC download. So we define a couple string variables, and we use the start bits transfer command to download the installer, and then a couple checks just to make sure that the proper file was downloaded. If the file is not there, it throws an error just saying, hey, there's no file here. And if the file is smaller than 5 megabytes, it lets you know that the file is too small. It's either the wrong file or something happened. So next we create a directory for the Windows Admin Center logs, and then a string for the name of the log file. And then we define the arguments for the start process command. And then we use start process to install Windows Admin Center. The neat thing about Windows Admin Center is there's still some GUI features like Notepad. And then in this instance, it will give us the wizard to configure Windows Admin Center. And then these are the steps that we'll take. If you don't reboot the server, you need to make sure that some specific services are running. And then at that point, this does not need to be here. At that point, the Windows Admin Center is up and running, and you can access it from this URL. So we'll come back to the PAW here in a bit. But for now, we're going to go ahead, download the installer file, and get him installed. I'm on a bit of a slower connection, so this will take just a moment. Okay, now we are installing, or we've launched the installer file, and now we will get a GUI installation wizard here in just a moment. So most of these settings we'll leave at the default. So we're going to do custom setup. And we're going to do remote access. So we're going to use the machine's fully qualified domain name to access. We're going to use the HTML form login, port 443. We'll use the pre-installed TLS, or excuse me, we will generate a self-signed certificate that will give us 60 days to experiment with. So this is great for labs. You can use a TLS certificate, which is also a good lab in and of itself. But if you're just trying to quickly stand up Windows Admin Center and look at it for 30 days, it's very simple to just generate the self-signed certificate. This will be the fully qualified domain name that we'll use to access the Windows Admin Center. And since this is a lab environment, we're going to set access. We're going to allow access to any computer. Since we're doing this in a lab environment, you might want to be more specific if this was production. But since this is a lab environment, allow access to any computer is fine. And then we're going to use HTTP for the default communication mechanism. This is talking about WinRM. Install the updates automatically. They can have the required diagnostic data. And then we will install Windows Admin Center. All right, and now we have officially finished the configuration. So before we stand up the PA, you don't necessarily need the PA. I just feel like it makes it more realistic. The PA is the privileged access workstation. You could also just call it like a management server. But the main thing is we just need a web browser to see Windows Admin Center. So you can actually do that from any device in the network. So just quickly before we stand up the PA, we'll just test the Windows Admin Center. How this works is in the web browser. It's HTTPS Yahoo wacko1.minecraftmoose.com. Oh, and excuse me. So this will not work because the service is not running on the WAC server. So we're going to bounce back to the WAC server. And the last step here. So first we'll just take a look at the service. It's stopped, right? It's not running. If you rebooted the server, it will start. But since we didn't do a reboot, we are going to want to start it. And now the service is running. So we'll bounce back over to our web browser. And now the connection is working. So that service was not running. We started it, and now everything is working. So it crosses out that HTTPS there, you see, because we chose HTTPE. Come down, click Advanced, continue anyway. And now we're at the login screen for our Windows Admin Center. So before diving into what that looks like, we're going to stand up a privileged access workstation quickly. So I'm just going to close him down. At this point, we can close our WAC. I'm not actually shutting them down. I'm just closing the management windows. So now we'll create our PA. And I'm going to give him 2 gigabytes of memory. A lot of labs, I try to do 1 gigabyte of memory. That's a good balance point between performance, running at the least amount of memory possible. You just, as these labs grow, you'll just find you just wish you had just a few more gigabytes of RAM but the 2 gigabytes really seems to be, I notice a big performance increase when I use 2 gigabytes of RAM. So when you do the initial configuration, it's just helpful to have the 2 gigabytes. And then like right now, we could turn off Anchorage DC01, set it to 1 gigabyte of memory, and then start it back up. That way, during the configuration process, it's not so sluggish and it's just more snappy. Okay, so we've got the privileged access workstation. It's up and running. So we'll go ahead and connect to him. I'm just going to get logged back into the RAS server so we can observe the DHCP. And for this one, all we're going to do is rename him and add him to the domain. Okay, we're back to the out-of-box experience. Program in my admin password. I'm just going to refresh it real quick. When you first connect in, you'll notice you get this RDP prompt. And if you don't see it, it might be a little buggy. So I always like to make sure I have that. All right, after he gets rebooted, we'll add him to the domain. So this just allows the computer to respond to ping, configuring a firewall rule for that, just testing that we have connectivity to the domain, and now we're going to add this computer to the domain. Come over here to our RAS server, hit refresh, and then we see Yahoo PA01 shows up in the DHCP lease list. Okay, the machine is joined to the domain. I'm going to use the MegaMan domain account. Oops, it's got a different password. Oh, that's an interesting one that has to do with permission. So we will actually just use the administrator account. Okay, so we're in here with the Minecraft Moose administrator account. And before we look at WAC, I'm just going to quickly also, we looked at the DHCP, we'll also just look at the computer object in Active Directory. Wrong password. And there is the paw. So now we'll move in to testing Windows Admin Center. So the idea is there's no workloads on this server. It's just a management server. And we're going to use it to access Windows Admin Center. So HTTPS Yahoo WAC01 Minecraft Moose.com. And advanced, continue. Okay, and so for this, I'm going to use Minecraft Moose Administrator. Oh, I had a typo there. All right, so we're on version 25.11 as of May 1st, 2026. So the only server that we have in here is the WAC gateway. So we'll just take a peek at him real quick. So we'll get some nice information about like the operating system, how much disk space is left, logged in users, the amount of gigabytes of RAM left. You can join the machine to Azure Arc. You can look at the installed apps, running processes, the registry. You can install roles and features. Look at services. Even look at the storage. So we can look at like the different disks and stuff. And one big thing they tout is the certificates. It's neat that behind one pane of glass you can quickly look at the certificates of different servers. So we're going to add the domain controller. So we'll click add server. We'll look for him in the Active Directory. Then he finds him. Also add our paw. And so this is one big thing that Microsoft wants us to know about Windows Admin Center, is that you operate behind one pane of glass. That's kind of the idea of centralization in the web browser. So now we're adding these machines in. So as you can see, there are some default tools, but Windows Admin Center is under constant development. And there's also other tools available in the extensions part of Windows Admin Center. So up here in the upper right, you click on Settings, Extensions, and then they have all these different neat extensions that you can use, like DHCP, And for this one, we want to do the Active Directory extension. So we'll install him. And another extension we'll install is DHCP. And DNS. So by default, you get all those standard tools. And then if you're looking for something in particular, they might have it here in extensions under settings. So we'll go back to the domain controller, and now we've got our Active Directory extension. It's still in beta, like preview, so there's not a whole lot of features. Like you can browse the organizational units. Like here's computers, and then here's PA01, WAC01, and then we can come in, and there's our interest synced users that we created earlier. Here is Iceman, Fireman, and then it has just a bit of information about them. Okay, and then the next thing we'll check out, so that was neat to look at the Active Directory. We also have this DNS. And so now we've got our different zones, and then we can see we've got our host A record for the domain controller and a CNAME record. Then we can also see the records for Yahoo WAC01 and PA01 and ANCDC01. So that's just kind of a quick basic demo of Windows Admin Center. It's really neat. It's where the industry is evolving. And this is how you set it up. One last piece is you can connect it to your Azure tenant. So you register it with Azure. So you pick Azure Global. We'll copy this code. This is for multi-factor authentication. Now we'll sign in with our global administrator account. And so this is a cloud-only account. There is no, this account is not in Active Directory. And I just have to do my multi-factor here. And that was an authentication window. So we've signed into Windows Admin Center. We may now close the window. We're going to create a new Microsoft Entra application, and we're going to connect to it. And this process will take just a moment here. So I may time compress the video here just a bit. Okay, and now we're prompted to sign in. And we've actually already authenticated. So we're just getting a few more prompts. And now we've registered this instance of Windows Admin Center to our Azure tenant. So the last thing I want to talk about before concluding the lab is on our Hyper-V router. So as you can see, everything's been working perfectly. We have access to the internet. We're getting DHCP addresses through the router. Everything is looking really good. But one odd thing I discovered, when you look at this in the GUI, it shows the services up and running, but none of the information that's normally here is here. And what I found, even though the configuration is set up, you still have to right click and go through the GUI wizard to configure. So if you don't want to do the command line and you want to set this up, you would just go into Tools, Routing and Remote Access, get into the Configuration GUI, and then right click on the server and then run through these configuration steps. And basically you just pick NAT, your external internet, your external interface, and then this just lists all your private ones. And then that's all that you have to do. And then normally it would take a moment for that to all get configured, but since we've done the configuration, it just instantly pops up with the graphical user information. And this is just convenient because you can look at all the different interfaces and quickly just see different statistics about them. So if you're using server desktop experience, you might as well just kind of use the GUI, because you'll have to do this anyway. If you even want to look at this, is the main thing. Normally I'm not too concerned. I just get everything up and going, use a server core image just to conserve a bit of disk space, and then that's what I use in my lab environment. But to demonstrate everything in this video, I just wanted to show I have discovered this little, I'm not sure if you call it a bug, but there's just an extra step there to display the information on the graphical user interface. So as you can see, our lab environment is using 2, 4, 6 gigabytes of RAM. So I found you get about half of the RAM available to your host that you can use to dedicate, that you can dedicate to standing up virtual machines. So what that means is, as your lab environments grow, you're going to need to turn off virtual machines. So in this case, I have 16 gigabytes. I can use about 8. So for the core configuration, I'm fine. But in future labs, I might not be so worried about Windows Admin Center. Or I might not be so worried about looking at everything through a dedicated PA. Like maybe I'm okay with just using the web browser on my domain controller. So depending on what your goal is, how your lab memory management is going, you'll need to turn off machines. So one thing to note, when you turn off a virtual machine, you can do it 3 ways: inside the guest operating system, or you can right-click, turn off, or shut down. And those are fine ways to turn off the virtual machine, but what happens is when you boot the virtual machine up, there is a spike in demand on the processor and the memory. So a better way to manage your memory is to save VMs when they're not in use. And so what saving a VM means is we have the option to save the operating system in its running state and then resume it later. So basically the computer gets booted up, it's up and it's running, and we save it in that running state and then resume to that running state, and we don't get that spike in processor and memory demand. So also they're all configured. We don't have to delete them. We can keep the configuration and then resume it at a later date and time. So to demonstrate this, we'll just pop back onto the PA. And so you'll see we've got this window up of Windows Admin Center, and then I'm also just going to run get date. So Friday, May 1st. We're going to save the VM. And now you can see the paw has been saved. It's not turned off, it's been saved. So now when we start it, the virtual machine does not have to go through the initial boot up process. It's just back to the state that it was in. And so we'll see our Windows Admin Center window and that PowerShell window displaying the date and time. So if we would have shut it down, we would have lost our Admin Center, this PowerShell window. But by saving and resuming, we can quickly get back to where we were. So if you're going to move on to like a storage lab next and you weren't really concerned about having a paw, you could just save him, save your WAC server. That way your WAC server, your paw, it's joined to your domain. There's no reason to delete it. You can just save them, and then now we've freed up 3 gigabytes of RAM to use for other virtual machines. So that will conclude the laboratory prerequisites lab. And so a fun way to end any lab is to destroy it. So I'm going to run the reset lab now. And then it's going to delete all of the virtual machines and their associated hard disks. And it's going to reset the lab back to how it was before we began. So here it's just shutting everything off. And then it will start nuking the hard disks. I might not get in there fast enough. Yes, so they're already deleted and all the virtual machines are gone. We're going to keep our switches because we're going to proceed on to more labs. Thank you for watching.